Asher's Mini Cartoons. Asher's Mini Cartoons. Asher's Mini Cartoons. Hello and welcome back. Today we are going to be learning about Isaac Newton's 3 laws of motion and forces such as friction and gravity. Physics is the study of mass and motion. It includes studies such as nuclear physics and electromagnetism. Newton's first law declares that objects at rest stay at rest, and objects in motion remain in motion unless a force is applied. For example, this cup is going to stay still unless a force is applied. And these pencils will stay in motion unless a force is applied. Wait, then why did they stop moving? That's because of a force called friction, which slows objects down by pushing them backwards. And when you throw something up, it would keep on going up if it weren't for a force called gravity, which pulls objects towards the earth. So technically, if we threw an object in outer space, it would keep on going up. His second law states that force is equal to mass times acceleration. Force is measured in newtons, mass is measured in kilograms, and acceleration is measured with meters per second squared. So for example, if I roll a tube of tape that weighs 0.2 kilograms and is going at 9 meters per second squared, the force in newtons would be 1.8. His third law shows that every action has an equal and opposite reaction. For example, the action of bouncing this volleyball causes the earth to push back on it with a tiny bit of acceleration. However, the Earth's mass is still an insane amount, which results in an equal force by the Earth and the volleyball. Now let's look at a couple examples with Newton's laws. Here, the force of my hand causes the rubber band to hit the blocks. The blocks react by falling and finally removing the weight holding down on the marble, allowing it to roll down the slope. Then, the marble knocks over the glue stick and keeps on going. If we were to calculate the mass and acceleration of the marble, we would have found out the force in newtons. For this next example, imagine you are in a bowling alley. The force of your hand allows the bowling ball to go forward. Also, gravity is pushing the ball down the incline. On the other hand, friction and air resistance are constantly slowing the ball down. The ball hits the pins, which hit the ground, bouncing and rolling around. In conclusion, Isaac Newton was an amazing scientist whose studies are still used around the world today. They demonstrate important parts of physics that were unheard of at his time. Thanks for watching. I hope you learned a thing or two, and we'll see you next time.